This tutorial introduces functions and recursive techniques. We will illustrate by example how to declare and use functions in our program and finally apply it in a recursive process. The topics that will be covered are: what is a function? Functions in programming. Syntax of a C++ function. What is a function? We have all used this term before in mathematics, so let us start from there. A function is a specific operation carried out on a particular set of values. It takes a single value x, which we will refer to as a parameter. Also, it produces a result which we will refer to as a return value. Now we will take a look at implementing functions generically in programming. At this point we should know about variable types. Here is how we define a function in many programming languages. We specify a type for the return value, the name of the function. Also any parameters the function may take, including their type and name. Here are some examples in C++. Let us look a little closer at these C++ examples. The first function named doThis returns the type integer and takes two parameters, one of type integer and another of type character. Now inside the parentheses, notice a return statement which returns 4, which is of type integer. This function has done nothing but return the integer 4. However, we are not limited to this and may design our function to do as we please with however many parameters required and return whatever type desired. The second function does just this, by manipulating the parameter and returning the result as a type double. We have seen the capabilities of functions and a general way of writing them. We now look at functions specifically for C++. C and C++ use a term called function prototypes. It is good practice to always declare function prototypes along with the function's definition. Some compilers may even complain if this is not followed. Just a note, prototypes are often placed in header files which you will see later. Here is how we write a function prototype and its corresponding function definition. The prototype, as before, has a return type, the function's name and any parameters taken. Notice however we end here with a semicolon. The accompanied function definition has the same return type, same name and parameters. However, here we use parentheses to define our desired actions. This example simply takes two integers and returns the sum as an integer. So we have written our function to add two numbers, but how do we actually use it? Here we will call our function from our main function. We specify the name of the function and any parameters it takes. Optionally, we may assign the return value of the function to a variable of same type as seen here, an integer. Note that we can call a function from any function. This includes the main function as we've shown in this example or any other function we have created. We can even call our function inside our function as we will see in recursive functions. We may ask why create functions. Functions allow us to split our code into manageable chunks, which in bigger projects is a great advantage. We can also test or debug these chunks individually and verify them as functional. Once they are verified, we can be certain that this piece of code will work when invoked. Thank you for taking time to watch this tutorial. I hope it was informative.